Solving radical equations. In this next section, we're going to go over different techniques on how to solve radical equations. For this first one, we need to isolate the radical. That's the general first step, is to isolate the radical. So I'm going to subtract 7 from both sides. That'll leave me with the square root of x equals 16 minus 7, which is 9. Now the next step is to get rid of the square root. To get rid of a square root, you have to square it to cancel it out. So you square both sides, and I have x equals 81. To check your work, you put that back in. So back in my original equation, I see that I have the square root of 81 plus 7 equals, does it equal 16? Square root of 81 is 9 plus 7. 9 plus 7 is 16. So this is true. So that's your checking your work. So your answer is x equals 81. For this next one, what we have to do is we start by adding the 5 over. That cancels out, leaving me with the square root of x equals 3. Then I have to get rid of the square root by squaring both sides. So that's going to leave me with x equals 9. Now I have to check my work. So the square root of 9 minus 5 equals negative 2. We want to know if that is equal. So square root of 9 is 3 minus 5, and that does equal negative 2. So it's true. And that's checking your work. For these next examples, we have square roots on both sides of the equal sign. When this is the case, we start by taking a square, by squaring both sides. Because if we start by doing that, then we can cancel them out, leaving me with 5t minus 11 equals t plus 5. Okay, so now I'm just solving for t. So I subtract this t over, leaving me with 4t minus 11 equals 5. And then I'm going to add the 11 over, giving me 4t equals 5 plus 11 is 16. Finally, I divide by the 4, and t equals 16 divided by 4 is 4. So that would be your final answer. And then if you check your work by substituting it back in, you see that 5 times 4 minus 11 is going to equal the square root of 5 times 4 is 20. 20 minus 11 is 9. Square root of 9, which is 3, which is equal to the square root of 4 plus 5, because 4 plus 5 is 9. So they are equal. So that means t equals 4 is your answer. For the next one, again, we're going to start by taking a square of both sides. So I get 7x minus 4 equals 5x plus 10. Now in solving, I'm going to subtract the 5x from both sides, leaving me with 2x minus 4 equals 10. So I'm going to add the 4 to both sides, and I have 2x equals 14. Then I divide by 2, so x equals 7. And then I can check my work by putting 7 in. So see if square root of 7 times 7 minus 4, is it equal to the square root of 5 times 7 plus 10? Well, that would be the square root of 49 minus 4, which is 45, and square root of 35 plus 10, which is 45. So it is true. So x equals 7 is your final answer. For these next few examples, we have to find any solutions that we get that don't work. Like we get the solution and it works out, but it doesn't work when we put it back in and check our work. Okay, so on this first one, I'm going to start, because my square root is already isolated, I'm going to start by squaring both sides. So I have n squared equals n plus 12. Now I know how to solve quadratic equations because I've done this before. So minus n and minus 12 to solve for 0. So n squared minus n minus 12 equals 0. At this point I factor. We've done this before. So I have n squared, n and n. Second sign is negative, so they're going to be opposite signs. And now I need to figure out my factors of 12 and then add them together to get a negative 1. So 12 would be 1 and 12, 2 and 6, 3 and 4. So it's going to be 3 and 4, and because I need to get a negative 1, so it's going to be a negative 4, positive 3. So now if I were to solve, n plus 3 equals 0, so n would equal a negative 3. And then n minus 4 equals 0, so n would equal 4. Now, those are my two solutions that I got, but I need to check to make sure they both work. So, does negative 3 equal the square root of negative 3 plus 12? Well, that would be the square root of 9, which is 3. So that is not always equal to it. So it can't be negative 3. So negative 3 is what we call an extraneous solution. It's not that it's not correct, because we did our math correct and we factored it out correct, but it doesn't always work when we put it back in. Okay, so the next one, we'll make sure that 4 works. So does 4 equal the square root of 4 plus 12? 4 plus 12 is 16. And the square root of, and so 4 equals the square root of 16. And that would be correct. So n equals 4 is your solution. For the next one, what we're going to do is we have to square both sides. So when we square this side, it's going to give me a y squared equals y plus 6. So y squared minus y minus 6 equals 0 when I do my subtraction to both the other side. So y and y, second sign is negative, so one's plus, one's minus, equals 0. So what I have to do is figure out my factors of 6, 1 and 6, 2 and 3. So because I need to get a negative 1, it's going to be a negative 3, positive 2. And now I have to check my work to make sure that they work, and they both work. So that would give me a, let's see, y plus 2 equals 0, so y equals negative 2. And y minus 3 equals 0, so y equals positive 3. We need to figure out which ones of those are real solutions. So the first one does negative, so if we're using the negative 2, so we're looking at negative, negative 2, is that equal to the square root of negative 2 plus 6? So double negative 2 is 2. Is that equal to the square root of 4? And it is. So that would be my final answer. Y equals negative 2 is a real solution. Now let's look at the other one to make sure the other one works. So I'd have negative 3 is that equal to the square root of 3 plus 6? So that would be the square root of 9, which is 3. So negative 3 is not equal to negative 3, or not equal to positive 3, so negative 3 is an extraneous solution. And that's your final answer. For these last two examples, we're going to just identify if there is a solution or not. So we're just going to solve the way we have been and then see if we come up with a correct solution. So we're going to start by isolating the square roots. So we're going to subtract 8 from both sides. It's going to give me a square root of 3y equals 2 minus 8, which is a negative 6. So then I'm going to square both sides. And I have 3y equals 36, because negative 6 squared is 36. So I'm going to then divide by 3. And y is equal to 12. Now I need to see if 12 works. So I have the square root of 3 times 12 plus 8, and I want to know if that is equal to 2. So 3 times 12 is 36. So I have the square root of 36 plus 8. Is that equal to 2? So 6 plus 8 is not equal to 2. 6 plus 8 is 14. So there's no solution. And 12 would then be extraneous. So this last example, we're going to start by subtracting the 6 from both sides. That's going to give me 4, negative square root 2x. Now I'm going to divide by a negative 1 to cancel out the negative here. So I have the square root of 2x equals a negative 4. Then I'm going to square both sides. So I have the square root of I have 2x equals 16. Negative 4 times negative 4 is positive 16. Then I divide by 2, and x equals 8. Now I need to figure out if that's a real solution. So when I do that, I see that I have 6 minus the square root of 2 times 8, and I want to know if that is equal to 10. So when I solve that out, 6 minus the square root of 16, is that equal to 10? That would give me 6 minus 4. And 6 minus 4 is actually 2, which is clearly not equal to 10. So there is no solution. And again, this would be extraneous. So that's your final answer, no solution on that. So those are your notes over solving radical equations and understanding extraneous and no solution results. Go through your practice problems, make sure you understand how to solve these and what their answers mean, and then you can take your quiz over this material.